The moon rises over the eastern horizon, a thin silver crescent hanging in the deepening blue of twilight. Perhaps we're watching from a village in ancient Sumer, or standing on a hillside in pre-dynastic Egypt, or gazing from a temple platform in early China. The specific place and time matter less than this timeless moment, this first glimpse of the new moon, the signal that a new month has begun. Across the ancient world, in cultures separated by vast distances and thousands of years, people watched the moon with careful attention, not casually, not just admiring its beauty, but observing with purpose, with need. The moon was humanity's first reliable calendar, its changing face marking time in a way that everyone could see, everyone could understand. No special instruments were needed, no mathematical training required. Just patient watching, night after night, as the moon told its story of time passing. We can imagine an elder, perhaps a priest or village wise person, standing in the gathering darkness, watching for that first crescent. They've been watching for 3 nights now, ever since the moon disappeared from the evening sky. 3 nights of darkness, of moonless nights when only starlight illuminated the world. But tonight, there it is. That delicate curve of light, the moon reborn, beginning its journey across the sky once more. The announcement goes out through the village. A new month has begun. Perhaps a conch shell is blown, or a drum beaten, or simply word passed from house to house. The calendars must be updated. The count begins again. Day 1 of the new month. Farmers will calculate planting times from this moment. Priests will determine when festivals should occur. Merchants will know when payments are due. Everything flows from this observation, this first glimpse of the returning moon. Over the coming nights, the moon will grow. Each evening, it appears a little fuller, a little brighter, setting a little later in the night. The watchers observe this growth with satisfaction, the natural order proceeding as it should. By the 7th night, roughly a week after the new moon, the moon appears half full, what we call the first quarter. This marks another important point in the month, another reference for measuring time. The moon continues to wax, growing fuller each night. By the 14th or 15th night, it rises in the east just as the sun sets in the west, hanging full and round in the darkening sky. This full moon is spectacular, bright enough to cast shadows, to allow nighttime activities that would be impossible in darker phases. Some cultures hold festivals at full moon, taking advantage of this natural illumination, celebrating the moon's completion. But the full moon is also a turning point. After this, the moon begins to wane, to decrease, entering the second half of its monthly cycle. Each night it rises a little later, appears a little less full. The timing becomes significant. If you want to see the moon, you must wait longer into the night. By the time it's waning crescent, just a thin sliver of light, it rises only in the hours before the dawn, visible briefly before the sun's light overwhelms it. Then comes the dark of the moon. 2 or 3 nights when no moon is visible at all. The night sky belongs entirely to stars during these moonless periods. Some cultures see this as a dangerous time when the moon has died and might not return. Others see it as a restful period, a natural pause before the cycle begins anew. Either way, people wait, watching the western sky at dusk, looking for that first crescent that signals the moon's rebirth. This cycle, from new moon to full and back to new, takes approximately 29.5 days. Not a round number, not perfectly aligned with the solar year, but consistent and observable. Ancient peoples built their calendars around this lunar month, accepting its imperfections, working with its rhythms rather than against them. In ancient Mesopotamia, the Sumerians and Babylonians developed sophisticated lunar calendars. Their months began with the first visibility of the new crescent, moon, observed from temple platforms by trained watchers. Each month had its name, associated with agricultural activities or religious festivals. The first month might be the month of barley harvest, another the month of brick-making, each name connecting the abstract passage of time to concrete human activities. But the lunar month presents a challenge. 12 lunar months total only about 354 days, 11 days shorter than the solar year. This means that a purely lunar calendar drifts. gradually getting out of sync with the seasons. A month that begins in spring one year might occur in summer the next, winter the following year. For agricultural societies, this presents serious problems. Planting and harvest depend on seasons, not arbitrary dates. The Mesopotamians solved this through careful observation and occasional adjustment. When they noticed the calendar drifting too far from seasonal markers, they added an extra month. This wasn't done randomly, but according to observed phenomena. If barley wasn't ready to harvest by the expected month, they added a second copy of the previous month, giving the crops time to mature and realigning the calendar with agricultural reality. The decision to add this intercalary month, this extra month, was made by the king or high priest. Observers would report their findings, astronomers would perform calculations, and an official decree would announce that this year would have 13 months instead of 12. This decree would be sent throughout the kingdom, ensuring everyone adjusted their calendars together, maintaining synchronization across the realm. In ancient Egypt, the situation was slightly different. The Egyptians observed both lunar cycles and the annual flooding of the Nile, developing a calendar that incorporated elements of both. The star Sirius played a crucial role. Its hyalactic rising, its first appearance in the dawn sky after a period of invisibility, coinciding remarkably well with the Nile's flood season. The Egyptian civil calendar eventually evolved to have 12 months of 30 days each, plus 5 extra days at the end of the year, creating a 365-day year. But alongside the civil calendar, they maintained the lunar observations for religious purposes. Certain festivals were timed to specific phases of the moon, requiring priests to track both calendaric systems simultaneously.
The full moon might be sacred to one deity, the new moon to another. The timing of rituals dependent on careful lunar observation. In ancient China, lunar observation was considered a sacred duty of the emperor. The calendar was an imperial prerogative, a symbol of the emperor's mandate to rule. Astronomers, working for the imperial court, observed the moon meticulously, determining the exact moment of new moon, calculating when months should begin. The announcement of the calendar was an annual ceremony, a demonstration of imperial authority, a gift from the emperor to his people. The Chinese developed sophisticated methods for predicting lunar phases. They understood that the moon's orbit wasn't perfectly regular, that calculations needed to account for various irregularities. Their astronomers kept detailed records, comparing predictions with observations, refining their methods over centuries. By the Han Dynasty, they could predict new moons with remarkable accuracy, allowing the calendar to be calculated years in advance. But even with mathematical sophistication, actual observation remained important. If a predicted new moon didn't appear when expected, or appeared earlier, adjustments were made. The moon itself was the ultimate authority. Calculations were tools for prediction, but observation was truth. This balance between mathematical prediction and empirical observation characterized Chinese astronomy for millennia. In the Islamic world, lunar observation takes on profound religious significance. The Islamic calendar is purely lunar, deliberately not adjusted to solar years. Each month is 29 or 30 days, determined by actual sighting of the new crescent moon. The start of important months, particularly Ramadan, depends on this observation. Communities wait for reliable witnesses to sight the new moon, their testimony determining when the month begins. This system means the Islamic calendar cycles through all seasons over a 33-year period. A month that occurs in winter one year might be in autumn the next, summer eventually, spring. This was intentional, ensuring that religious obligations weren't tied to specific seasons, that all believers would experience fasting and pilgrimage in all weather conditions over the course of their lives. The actual sighting of the new crescent presents challenges. The moon must be above the horizon after sunset, far enough from the sun to be visible, and the sky must be clear. The first crescent is often difficult to see, requiring clear skies, experienced observers, favorable atmospheric conditions. Sometimes debates arise about whether the moon was truly seen, whether testimony is reliable, whether the month has genuinely begun. Different communities might begin months on different days based on local sighting or decisions to follow distant authorities. In modern times, this has led to discussions about using calculations rather than sighting, but many Muslims prefer maintaining the traditional practice of observation, connecting them to centuries of lunar watchers, to the original practice established by the Prophet. The Hebrew calendar, used for religious purposes in Judaism, is a lunisolar calendar, meaning it tracks both moon and sun. Months are lunar, beginning with the new moon, but years are adjusted to solar cycles through a complex system of intercalation. 7 times every 19 years, an extra month is added, a 13th month called Adar II, ensuring that festivals occur in their proper seasons. This 19-year cycle, sometimes called the Metonic cycle after the Greek astronomer who described it, reflects a remarkable astronomical coincidence. 19 solar years almost exactly equal 235 lunar months. Not perfectly, there's a small difference, but close enough that a calendar based on this cycle remains aligned with both sun and moon over centuries. The calculation of the Hebrew calendar involves complex rules, determining not just when extra months should be added, but also adjusting the lengths of certain months to ensure that holidays don't fall on problematic days. Rosh Hashanah, the Jewish New Year, cannot fall on Sunday, Wednesday, or Friday, requiring sometimes subtle adjustments to make the calendar work within religious constraints. Despite these complications, the lunar component remains central. Each month still begins with the new moon. The full moon falls in the middle of the month, marking important festivals like Passover and Sukkot. The waxing and waning of the moon structures religious life, just as it did for ancient peoples worldwide, connecting modern practice to timeless celestial rhythms. In ancient Greece, the situation was remarkably complex. Different city-states maintained their own calendars, each with different month names, different ways of handling intercalation, different starting points for the year. Athens might be in one month while Sparta was in another, making coordination difficult, but reflecting the independence of each city-state. The Athenian calendar was lunar, with months beginning at the new moon, but adjusted to solar years through irregular intercalation. The decision to add an extra month was made by officials, sometimes for astronomical reasons, sometimes for political convenience. A ruler might insert an extra month to extend their term of office, or compress the year to hasten an election. The calendar became a tool of political manipulation as much as an astronomical instrument. Greek astronomers, however, understood the challenges. Meton proposed his 19-year cycle. Callippus refined it further. These mathematical solutions provided frameworks for maintaining calendrical order, even if political realities often interfered with their implementation. The tension between astronomical precision and political convenience characterized Greek timekeeping for centuries. In the Celtic world, though written records are sparse, we can infer that lunar observation was important. The Coligny calendar, a fragmentary bronze calendar from Gaul, shows a sophisticated understanding of lunar solar cycles. It divides years into light halves and dark halves, months into light fortnights and dark fortnights, reflecting careful observation of both moon and sun. The Druids, the priestly class of Celtic society, were said to be skilled astronomers, masters of calendrical knowledge. They determined when festivals should occur, when kings should perform certain rituals, when agricultural activities should begin. This knowledge was kept oral, never written, transmitted from teacher to student through careful memorization, making the Druids indispensable to their communities. The Celtic preference for beginning days at sunset rather than sunrise reflects lunar thinking. The moon is most visible at night. Its phase is most apparent in darkness. By beginning the day at dusk, they aligned daily time with lunar time, seeing the darkening sky as the beginning rather than the end, a perspective that made sense in a lunar-based system. Among many Native American peoples, lunar observations structured time. Each full moon had its name, reflecting seasonal activities or natural phenomena. The snow moon, the harvest moon, the hunter's moon. These names connected lunar cycles to annual patterns, providing a calendar that was both astronomical and ecological, tied to the rhythms of nature. Different nations had different names, reflecting their particular environments and practices. Coastal peoples might have moons named for fishing activities, agricultural peoples for planting cycles, hunting peoples for animal behavior. But the underlying pattern was universal. 13 or so lunations per year, each marking a specific time, a specific set of activities. The observation was often communal. When the full moon rose, people gathered, shared the moment, perhaps held ceremonies or told stories. The moon became a social coordinator, bringing people together at predictable times, creating shared temporal experience. In ancient societies without written calendars, this gathering around celestial events maintained social cohesion, synchronized activities across dispersed communities. The phase of the moon affected practical activities. Full moons provided light for nighttime hunting or fishing. New moons, being dark, might be avoided for travel or chosen for activities requiring secrecy. The waxing moon was often seen as favorable for beginning projects, the waning moon for completion or ending. These beliefs, whether based on practical considerations or symbolic thinking, shaped how people organized their lives around lunar cycles. In ancient India, lunar calculations reached extraordinary sophistication. Indian astronomers developed complex mathematical models for predicting lunar positions, calculating eclipse possibilities, determining exact moments of new and full moons. The Surya Siddhanta, an astronomical text, provides detailed algorithms for these calculations, showing mathematical astronomy at its most advanced. Yet even with this sophistication, observation remained important. Calculation provided predictions, but the actual moon was the authority. If predictions differed from observation, it was the calculation that needed adjustment, not the moon. This humility before empirical reality, even in the face of impressive mathematical achievement, characterized Indian astronomical tradition. The Hindu calendar is lunisolar, with months beginning at new or full moon, depending on regional tradition. Extra months are added according to complex rules, maintaining alignment with solar year. Religious festivals are timed to specific tithis, lunar days, which don't correspond exactly to solar days, requiring careful calculation to determine proper timing. The importance of these calculations meant that astronomical knowledge was highly valued. Brahmins trained in Jyotisha, astronomical calculation, were essential to proper ritual timing. Kings employed court astronomers to ensure ceremonies occurred at auspicious times. The connection between astronomy and astrology, between calculating celestial positions and interpreting their meaning, was seamless, both aspects of the same tradition. In ancient Mesoamerica, particularly among the Maya, lunar calculation achieved remarkable precision. Maya astronomers tracked lunar cycles over centuries, developing extremely accurate values for the synodic month, the time from new moon to new moon. Their eclipse tables could predict lunar eclipses over long periods, demonstrating centuries of careful observation and mathematical refinement. The Maya used multiple calendar systems simultaneously. The Ha'ab, a 365-day solar year, the Cholkin, a 260-day ritual calendar, and lunar calculations that provided another layer of temporal organization. These systems interlocked in complex ways, creating cycles within cycles, patterns that repeated over vast periods. The famous long count calendar tracked days from a mythical starting point, but lunar phases provided shorter cycles for practical use. Maya observers watched from temple platforms, recording moon positions relative to stars and horizon features. Their codices show detailed astronomical tables, including lunar data. The Dresden Codex, one of the few surviving Maya books, contains extensive eclipse tables, showing when eclipses might occur, what type they would be, demonstrating the sophistication of Maya lunar astronomy. The observation of the moon wasn't just scientific, but deeply religious. The moon deity, in various forms across Mesoamerican cultures, was associated with fertility, water, the cycles of life. Lunar eclipses were significant events, interpreted as moments of cosmic drama, requiring rituals to ensure the moon's safe return. The practical astronomy and religious significance were inseparable, both aspects of understanding cosmic order. In ancient Rome, the calendar began as lunar, but evolved toward solar. Early Roman months were lunar, beginning with the new moon, with an official called the Pontifex, responsible for announcing when new months began. The Pontifex would watch for the new moon, then announce calare, from which comes our word calendar, that the month had started. But the Roman system became increasingly disorganized. Pontifices sometimes manipulated the calendar for political purposes, adding or omitting days or months to extend terms of allies or shorten those of opponents. By Julius Caesar's time, the calendar had drifted badly out of sync with seasons, requiring major reform. Julius's Julian calendar, introduced in 45 BCE, broke from lunar months entirely. It established fixed month lengths totaling 365 days with an extra day every 4 years, abandoning lunar observation for mathematical regularity. This was revolutionary, choosing calculation over observation, artificial months over natural lunar cycles. Yet lunar observation didn't disappear. Christian Easter centuries later would be calculated based on lunar cycles, occurring on the first Sunday after the first full moon following the spring equinox. This complex rule requires tracking both solar position and lunar phase, maintaining a connection to lunar timekeeping within an otherwise solar calendar. The gradual shift from lunar to solar calendars, or to purely calculated calendars, represents a significant change in human relationship with time. Lunar calendars required ongoing observation, constant attention to the sky, regular adjustment based on what was actually seen. They connected people to celestial rhythms, made them active participants in timekeeping. Calculated calendars, by contrast, allow passive following of predetermined patterns. You don't need to watch the sky, just consult the calendar. This brings convenience and precision, but also a certain disconnection. Time becomes abstract, mathematical, less tied to observable nature. The trade-off between accuracy and experiential connection continues to shape how different cultures approach calendars today. But even in modern times, with atomic clocks and GPS satellites, the moon continues to mark time in its ancient way. It waxes and wanes regardless of human calendars or calculations. Fishermen still watch its phases, planning activities around tides that follow lunar rhythms. Gardeners use moon phases to time planting, whether based on tradition or personal belief. The Islamic world still watches for that first crescent, maintaining an unbroken tradition of lunar observation stretching back centuries. There's something deeply satisfying about lunar timekeeping. The moon is visible, obvious, its changes apparent to everyone. Unlike the subtle shift of constellations marking solar years, or the invisible movements of planets requiring careful tracking, the moon wears its changes openly. A child can understand moon phases, can see the pattern, can learn to anticipate what comes next. This accessibility made lunar calendars humanity's first widespread timekeeping system. Before writing, before mathematics, before complex astronomical knowledge, people could watch the moon and know where they were in the month. Hunters could plan by its light. Gatherers could time activities to lunar cycles. Communities could coordinate gatherings without need for written notice, just watching the sky together. The moon also connects to human biology in ways that solar cycles don't. The lunar month approximates human menstrual cycles, connecting female fertility to celestial rhythms. Many cultures noted this connection, building mythologies around it, seeing the moon as particularly connected to women, to birth, to the cycles of life. Whether this connection is causal or coincidental remains debated, but the association is ancient and widespread. Lunar observation also teaches patience. Unlike the quick movements of clouds or the sudden arrival of storms, the moon changes slowly. You must watch night after night to see its transformation. This slow pace encourages contemplative observation, makes timekeeping a meditative practice rather than a quick check. The moon rewards sustained attention, revealing its patterns only to those who watch regularly. In our artificially lit modern world, many people rarely see the moon clearly. Light pollution washes out subtle details. Buildings block views of horizons. Indoor life disconnects us from nightly celestial displays. Yet, for most of human history, the moon was impossible to ignore. Its presence undeniable, its changes obvious. Evening activities naturally synchronized with its light. Darkness deepening as it waned, nights brightening as it waxed. The loss of this connection represents something significant. We've gained precision in timekeeping, lost connection to celestial rhythms. We know exactly what time it is, down to the second, but may not know what phase the moon is in, when it will rise or set. This knowledge, once universal, has become specialized, something only astronomers or enthusiasts maintain. Yet the moon persists in marking time, as it has for billions of years, as it will for billions more. The same moon that ancient Sumerians watched, that Egyptian priests observed, that Chinese astronomers tracked, that continues to determine Islamic months, still hangs in our sky, still waxes and wanes in its ancient pattern. Its rhythm continues, whether we watch or not, whether we use it for calendars or not, a cosmic metronome ticking away the months. And perhaps there's value in reconnecting with this ancient timekeeper, not replacing modern calendars, but supplementing them, adding a layer of connection to natural cycles, watching the moon wax and wane, noticing how its rising time shifts, observing how its light changes the nighttime landscape. Simple observation, no instruments required, just patient attention to the sky. The full moon rising on a clear night is still spectacular. That moment when it appears on the horizon, huge and golden, gradually climbing higher, shrinking and whitening as it rises. The way it illuminates landscapes, casting soft shadows, turning night into a gentle twilight.
This experience was once monthly routine, now often missed, but available to anyone who chooses to watch. The new crescent moon, that delicate first appearance after several dark nights, remains as beautiful as ever. The challenge of spotting it, of being the first to see the new month begin, this ancient practice is still possible. Standing at sunset, watching the western sky, waiting for that first glimpse of silver light, the satisfaction when it appears, the connection to millennia of previous watchers, this experience transcends time. The moon teaches us that time is both linear and cyclical. The moon returns to the same phase, yet each lunation is different, occurring in different seasons, different stellar contexts. This interplay of repetition and change reflects the nature of time itself. Patterns that repeat but never exactly, cycles that continue but always in new contexts. For ancient peoples, this was lived experience, not abstract philosophy. They watched the moon return to fullness 12 or 13 times a year, saw how each full moon was unique despite the pattern repeating. They understood implicitly what we now express mathematically, that lunar and solar cycles don't align perfectly, that nature resists perfect regularity. This slight irregularity, this refusal to fit neat patterns, characterizes much of nature. The lunar month isn't exactly 29.5 days. The solar year isn't exactly 365.25 days. Even these numbers are approximations. Reality is messier, requires constant small adjustments. Ancient calendars, with their occasional extra months, their flexible day counts, their observation-based adjustments, accommodated this messiness more honestly than modern calendars that hide irregularities in leap year rules and ignore decimal places. Perhaps this is the deepest lesson of lunar calendars. They teach us to work with nature's rhythms rather than imposing arbitrary order, to observe, to adjust, to remain flexible, to accept that perfect regularity is impossible, that ongoing attention and adjustment are necessary. These aren't weaknesses, but reflections of reality, of the complex gravitational dance of Earth, Moon, and Sun that creates the time we experience. As we drift toward sleep, we can imagine watching with those ancient observers, standing on a ziggurat in Babylon, a temple platform in Egypt, a hillside in ancient Britain, waiting for that first crescent or watching the full moon rise, feeling connected to the vast cycles of cosmic time, to the billions of years the moon has circled Earth, to the billions more it will continue. The moon watches over us as we sleep, whether we see it or not, rising, crossing the sky, setting in its ancient pattern, pulling at Earth's oceans, creating tides that ebb and flow, reflecting sunlight in gradually changing amounts, waxing, waning, disappearing, reappearing. The eternal cycle continuing, regardless of human attention, regardless of calendars or calculations. And in the morning, or tomorrow night, or whenever we next glance skyward, the moon will be there, slightly different, slightly changed, marking time in its patient, inevitable way. A reminder that some rhythms transcend human invention, that some cycles preceded civilization and will outlast it. That time, at its most fundamental, lunar timekeeping is written in the sky, in the slow dance of celestial bodies, in the eternal waxing and waning of the moon. The practical details of lunar observation in different cultures reveal how deeply embedded this practice was in daily life. In ancient Babylon, the watchers didn't simply glance at the sky and announce a new month. They had specific criteria, detailed rules for what constituted a valid sighting. The crescent had to be visible for a certain duration, at a specific angle from the sun, clear enough that multiple observers could confirm it. If clouds obscured the view, or if atmospheric conditions made observation impossible,
They had procedures for estimating when the month should begin based on previous cycles. These watchers were trained from youth, learning to recognize the subtle variations in crescent visibility. They understood that atmospheric conditions affected observation, that dust or humidity could delay visibility by a day. They knew that the moon's orbit varied slightly, that some months the crescent appeared earlier or later than the average 29.5-day cycle would suggest. This empirical knowledge, accumulated over generations, made them expert observers, able to make accurate determinations even in challenging conditions. The announcement of the new moon in ancient Mesopotamia was ceremonial. The watchers would report to temple officials, who would verify the observation, and then the announcement would be made official. Messengers carried word to distant cities, ensuring that the entire region synchronized their calendars. This communication network, maintained for calendrical purposes, also served other functions, creating connections between cities, facilitating trade and political coordination. In ancient Israel, the Sanhedrin, the high court, received testimony from moon watchers. Witnesses would come before the court, describe what they had seen, answer questions about the exact circumstances of their observation. The court would evaluate their testimony, determine its validity, and then officially declare the new month. This legal process around lunar observation shows how seriously calendrical accuracy was taken, how the determination of time was a matter of highest importance. The testimony of women was generally not accepted in ancient Jewish courts, but for lunar observation, there are records suggesting some flexibility. The observation of the new moon was considered so important and good observers so valuable that the rules might bend to ensure accurate determination. This pragmatism around calendrical needs, overriding usual social restrictions, demonstrates the critical nature of timekeeping in ancient societies. The new moon itself, that moment of conjunction when the moon passes between Earth and Sun, is invisible. What observers watched for was the first crescent, appearing shortly after conjunction. This meant there was inherent uncertainty in the system. The first visible crescent might appear 18 hours after conjunction, or 48 hours, depending on numerous factors. This variability meant that lunar calendars required ongoing observation, couldn't be perfectly predicted far in advance. Some cultures developed tables based on historical observations that predicted likely visibility. These tables accounted for seasonal variations, the moon's changing distance from Earth, atmospheric factors, but they remained guides rather than definitive answers. The actual observation always took precedence, maintaining the observational character of lunar timekeeping. The Islamic practice of moon sighting continues these ancient traditions. In many Muslim communities, local religious authorities watch for the new crescent of certain months, particularly Ramadan and Shawwal, which mark the beginning and end of the fasting month. The sighting is often done by committees, groups of trained observers at locations with clear western horizons, watching the sky after sunset. The testimony of reliable witnesses is crucial. In some countries, witnesses must be known in the community, of good character, experienced in moon observation. They describe not just that they saw the crescent, but its angle, thickness, how long it remained visible. This detailed testimony helps authorities determine whether a genuine sighting occurred or whether witnesses might have mistaken another celestial object for the moon. Modern technology has complicated this ancient practice. Telescopes can detect crescents invisible to the naked eye. Photographic equipment can capture images. But many Islamic scholars maintain that the tradition requires actual eye observation, not technological assistance. This creates interesting debates about what constitutes valid observation, how ancient practices should adapt to modern capabilities. Some Muslim countries use astronomical calculations to predict crescent visibility, announcing months in advance. Others insist on physical sighting. Still others accept sighting reports from other regions, even if the moon isn't visible locally. These variations reflect different interpretations of religious requirements, different balances between tradition and technology, different understandings of what lunar observation means. The difficulty of observation, particularly in urban areas with light pollution and limited horizons, has led some communities to send observers to remote locations. Groups might travel to deserts or mountains, seeking clear skies and unobstructed views. This pilgrimage for moonwatching, this journey to favorable observation sites, connects modern practices to ancient traditions of watchers traveling to temple platforms or high places for better views. The psychological aspects of moonwatching deserve attention. Waiting for the crescent to appear, scanning the twilight sky, requires patience and focus. The observers must maintain concentration even as light fades, as the ideal viewing window is brief. Too early and the sky is too bright. Too late and the moon has set. This focused waiting, this concentrated observation creates a meditative state, connecting the observer to their task in a way that passive calendar consultation never could. When the crescent finally appears, there's a moment of satisfaction, of accomplishment. The observer has fulfilled their duty, has successfully detected the subtle signal that a new month begins. This emotional reward, this sense of achievement, reinforced the practice across generations. Moonwatching wasn't just functional, it was meaningful, connecting observers to cosmic cycles in a personally significant way. The difficulty of observation also created community bonds. Successful moonwatchers were respected, their testimony valued. They held positions of trust, their observations affecting everyone's activities. This social role, this responsibility, made lunar observation more than astronomical practice. It was social glue, binding communities through shared temporal experience. In ancient Egypt, the situation was uniquely complex because of the Nile's central importance. The river's annual flood was the defining event of the Egyptian year, far more significant than any celestial cycle. Yet the flood's timing correlated remarkably well with astronomical events, particularly the heliacal rising of Sirius, which occurred around the same time as the flood's beginning. The Egyptians developed a civil calendar, divorced from both lunar and solar cycles, having 12 30-day months plus 5 extra days. But they maintained lunar observations for religious purposes, certain festivals timed to moon phases regardless of civil date. This dual system, civil calendar for administration and agriculture, lunar observation for religion, shows the complexity of ancient timekeeping. Temple records from Egypt show careful tracking of both calendars. Priests needed to know both civil dates and lunar phases to ensure proper timing of all activities. Some temples had dual calendars inscribed on walls, allowing priests to convert between systems. This coordination between different temporal frameworks, this ability to think in multiple time schemes simultaneously, demonstrates sophisticated temporal thinking. The relationship between lunar cycles and the Nile flood, while correlating, wasn't perfectly consistent. Some years the flood came early, others late. The Egyptians noticed this variability, tracked it over centuries, understood that both lunar and stellar observations needed to be combined with direct monitoring of river conditions. This integration of multiple observation systems, celestial and terrestrial, shows the pragmatic approach ancient cultures took to timekeeping. Egyptian moon gods, particularly Thoth and Khonsu, were associated with time, writing, calculation. Thoth was said to have won 5 extra days from the moon god Khonsu in a game of Senet, explaining the 5 days beyond 12 30-day months. These myths encoded calendrical knowledge, making abstract temporal concepts concrete through story, helping people remember and transmit calendrical information. Temple reliefs show lunar observations, priests with raised arms marking celestial events. These images, while stylized, suggest ritual dimensions to astronomical observation. The watching wasn't purely technical, it was also ceremonial, connecting human observers to divine order. The moon was simultaneously a practical timekeeper and a divine presence, its observation both scientific and religious. The Chinese approach to lunar observation was similarly complex. Imperial astronomers tracked moon phases, predicted new moons, calculated eclipses, but they also interpreted celestial events, looking for omens, understanding astronomical phenomena as communications from heaven about earthly affairs. This dual nature, technical calculation and symbolic interpretation, characterized Chinese astronomy for millennia. The Imperial Calendar Bureau employed numerous astronomers, mathematicians, observers. They worked in shifts, ensuring continuous sky observation. Their predictions were checked against reality, and any discrepancies investigated. Failed predictions could cost astronomers their positions or worse, creating strong incentives for accuracy. This pressure produced increasingly sophisticated methods, generation after generation of refinement. Chinese lunar tables, developed over centuries, tracked the moon's position with remarkable precision. They accounted for the moon's varying speed, its changing orbital distance, the effects of solar and lunar gravity on its motion. These corrections, discovered through centuries of observation and calculation, produced predictions accurate to within hours, extraordinary achievement for ancient astronomy. The Chinese also developed detailed theories about why the moon's motion varied. They understood, though not in modern terms, that gravitational forces were involved. They created geometric models, mathematical descriptions trying to explain observed irregularities. This theoretical work, this search for underlying causes, shows that ancient astronomy wasn't just prediction but understanding. Chinese culture celebrated certain lunar phases particularly. The Mid-Autumn Festival, timed to the full moon of the 8th lunar month, was a major celebration. Families gathered, ate special foods, watched the moon together. The moon at this time was said to be brightest and roundest, though astronomical reality doesn't support this, showing how cultural belief sometimes diverged from astronomical fact. The moon's association with reunion, with family, with harmony, runs deep in Chinese culture. The full moon symbolizes completeness, wholeness, perfection. Separated family members would look at the full moon simultaneously, feeling connected across distance by their shared observation of the same celestial object. This emotional connection to lunar phases, this use of the moon for maintaining social bonds, transcends its practical timekeeping function. In ancient India, lunar calculations were intertwined with religious obligations. The timing of rituals, the determination of auspicious moments, required precise knowledge of lunar position and phase. Astronomers calculated tithis, lunar days, which don't align with solar days, requiring complex conversion between different temporal systems. A tithi is 1/30th of a lunar month, the time the moon travels 12 degrees relative to the sun. Since the moon's speed varies, tithis have different lengths, some longer than solar days, some shorter. A solar day might contain 1 tithi, or 2, or occasionally none, creating complex calendrical situations that required expert calculation. Religious texts prescribed specific tithis for specific rituals. Missing the correct tithi, performing a ceremony at the wrong lunar moment, could invalidate the ritual. This made astronomical knowledge essential to religious life. Brahmins trained in Jyotisha, astronomical calculation, were indispensable to proper religious observance, their knowledge connecting earthly ritual to cosmic timing. The accuracy required for religious purposes drove astronomical development. Observatories were built, instruments developed, mathematical methods refined. The Jantar Mantar observatories, built in various Indian cities, included massive masonry instruments for tracking celestial positions. These weren't just scientific instruments, but religious necessities, tools for ensuring cosmic harmony through properly timed ritual. Indian astronomers understood that eclipse predictions required accurate lunar tables. Eclipses were religiously significant, requiring specific rituals, special observances. The ability to predict eclipses, to know when they would occur, where they would be visible, demonstrated both technical prowess and religious authority. Failed predictions damaged credibility. Successful ones enhanced status. The relationship between observation and calculation in Indian astronomy was balanced carefully. Observations provided data. Calculations made predictions, but observations ultimately verified calculations. If prediction and observation diverged, the calculation needed refinement, not the observation. This empirical approach, this willingness to adjust theory to match reality, characterized Indian astronomical tradition. Among the Maya, lunar calculation achieved extraordinary precision. The Dresden Codex, one of the few surviving Maya books, contains detailed lunar tables. These tables track the synodic month, the time from new moon to new moon, with remarkable accuracy. The Maya value, derived from centuries of observation, is accurate to about 2 hours per year, extraordinary for ancient naked-eye astronomy. The Maya astronomers understood that eclipses followed patterns. They discovered the Saros cycle, a period of about 18 years after which eclipse patterns repeat. This knowledge allowed them to predict eclipses far into the future, creating tables showing when eclipses might occur. These predictions weren't perfect. Not every predicted eclipse was visible from Maya territory, but the patterns were real, demonstrating deep understanding of lunar motion. The lunar deity in Maya culture, often depicted as a young woman, was associated with fertility, water, the cycles of life. Lunar eclipses were seen as dangerous moments, times when the moon goddess was threatened. Rituals were performed, drums beaten, prayers offered to help the moon survive its darkening. The astronomical knowledge and religious interpretation were inseparable, both aspects of understanding cosmic order. Maya inscriptions record lunar ages, how many days since the previous new moon. This information, carved in stone, served both practical and ceremonial purposes. It dated events within the lunar cycle, connected earthly happenings to celestial patterns. The precision with which these lunar ages were recorded, often to the exact day, shows the importance of lunar timekeeping in Maya culture. The Maya also tracked the lunar nodal cycle, the roughly 18.6-year period during which the moon's orbital plane precesses. This cycle affects eclipse patterns, the extreme positions where the moon rises and sets, various other phenomena. Knowledge of this cycle, which requires decades of observation to discern, demonstrates the long-term continuity of Maya astronomical observation. In ancient Britain, the megalithic monuments suggest lunar observation. Some stone circles and henges have alignments to lunar standstills, the extreme positions of moonrise and moonset that occur every 18.6 years. These alignments, if intentional, would require decades of observation, recognition of the nodal cycle, planning monuments to mark these extreme positions. The evidence is debated. Not all archaeoastronomers accept lunar alignments at megalithic sites, but the possibility suggests that even in prehistoric Britain, lunar observation was sophisticated enough to recognize long-term cycles. The effort required to build these monuments, aligning massive stones to mark celestial events, indicates the significance placed on astronomical observation. If these alignments are real, they represent extraordinary dedication to lunar observation. A watcher would need to observe the moon rising over many years, tracking how its rising position varies, recognizing the 18.6-year cycle, and then convincing their community to build lasting monuments marking these positions. This requires both astronomical knowledge and social organization, connecting celestial observation to community effort. The Druids, according to classical authors, were skilled in astronomical calculation. Whether they actually observed lunar standstills, whether they used such knowledge in their practices, remains uncertain. But the association of Druids with astronomical knowledge, with timing of festivals and rituals, suggests that lunar observation was part of their expertise. The Celtic quarter-day festivals, Imbolc, Beltane, Lughnasadh, Samhain, are often described as solar festivals. marking midpoints between solstices and equinoxes. But some scholars suggest lunar components, that celebration dates might have been modified by lunar phases, that the combination of solar and lunar timing created the actual festival calendar. This possibility would make Celtic timekeeping lunisolar, similar to other ancient systems. Among various African cultures, lunar observations structured time. The Bakongo people, for example, had detailed lunar calendars with names for each phase, associations with specific activities. Fishing, hunting, agricultural work, all timed to moon phases based on generations of accumulated observation. The full moon often triggered communal gatherings. People would assemble, share news, resolve disputes, conduct ceremonies. The moon provided a natural coordinator, its brightness allowing nighttime activities impossible during darker phases. These full moon gatherings, occurring monthly, maintained social bonds, reinforced community identity, provided regular opportunities for collective action. Different lunar phases suggested different activities. The waxing moon, seen as a time of growth, was favorable for planting. The full moon's brightness aided nighttime fishing or hunting. The waning moon might be for harvesting, for activities associated with decrease or completion. These associations, whether based on practical experience or symbolic thinking, created a rhythm to life, activities rising and falling with lunar cycles. Oral traditions transmitted lunar knowledge across generations. Elders taught young people to observe, to recognize phases, to know what activities each phase favored. This knowledge was practical, determining success in fishing, farming, hunting, but it was also cultural identity, a way of understanding time that connected people to land, to ancestors, to cosmic patterns. The spread of solar calendars, first through Islamic influence, later through colonialism, disrupted these traditional lunar systems. Yet, many communities maintained lunar knowledge, using it alongside imposed calendars. Market days might follow solar weeks, but agricultural activities still responded to moon phases. This dual timekeeping, official and traditional, continues in many places today. The persistence of lunar observation, despite replacement by solar calendars, suggests deep human connections to lunar cycles. The moon's visibility, its obvious changes, make it personally accessible in ways that solar calendars aren't. You can see the moon, watch its transformation, feel connected to temporal cycles in immediate, sensory ways. Modern research has investigated possible connections between lunar cycles and biological phenomena. Do animals respond to lunar phases? Do plant growth patterns correlate with moon position? The evidence is mixed. Some correlations found, others not, but the investigation continues. The possibility that lunar cycles affect terrestrial life, that ancient peoples' associations between moon and fertility or growth had basis in reality, remains open. Tides provide clear lunar influence on Earth. The moon's gravity, combined with the sun's, creates the twice-daily rise and fall of ocean waters. Coastal peoples worldwide have understood this connection, used tidal knowledge for navigation, fishing, gathering seafood. The timing of tides shifts with the moon's position, creating another way lunar cycles affect human activities. Spring tides, the highest tides occurring at new moon and full moon, when sun and moon align, were particularly important. These extreme tides exposed resources usually underwater, allowed access to certain fishing areas, created opportunities for specific gathering activities. Knowing when spring tides would occur, predicting their timing based on lunar phases, was crucial knowledge for coastal communities. Neap tides, the lowest tides, occurring at quarter moons when sun and moon are at right angles, presented different opportunities and challenges. The reduced tidal range affected navigation, changed fishing patterns, required different strategies. Understanding this monthly tidal cycle Its connection to lunar phases demonstrates practical importance of lunar observation beyond pure timekeeping. Some traditional navigation systems incorporated lunar knowledge. Polynesian navigators, for example, used multiple environmental cues, including lunar position and phase, for long-distance ocean travel. The moon's position provided directional information at night. Its phase indicated timing within the month. Its interaction with tides affected voyage planning. The moon as a nighttime light source influenced many activities.
Travelers preferred full moon for nighttime journeying when roads and paths were visible. Traders timed caravans to have moonlight during dangerous portions of routes. Military campaigns often avoided new moon periods when darkness aided surprise attacks. The lunar cycle thus affected not just timekeeping, but all nighttime activities. Agricultural practices worldwide incorporated lunar timing. Planting, pruning, harvesting, all might be timed to specific moon phases. The logic varied, some based on tidal theory, some on traditional belief, some on observed correlation. Modern studies show mixed results. Some lunar planting claims supported, others not. But the practice continues in many farming communities. The farmer's almanac tradition, found in various cultures, combined solar calendar dates with lunar phase information, providing guidance for agricultural timing. These almanacs represented accumulated traditional knowledge, observation-based wisdom passed down through generations. Whether the lunar correlations are causal or coincidental, the almanacs served their purpose, helping farmers time activities successfully. Even in industrialized societies, some farmers maintain lunar planting traditions. Biodynamic agriculture, for example, incorporates lunar and planetary positions into farming practices. Organic growers sometimes follow lunar planting calendars. This persistence of lunar agricultural timing, despite scientific skepticism, suggests either continued validity or deep cultural persistence of ancient practices. The moon's changing appearance also inspired countless myths and stories. Why does the moon change shape? Why does it disappear and return? Cultures worldwide created narratives explaining lunar phases, stories that simultaneously entertained, educated, and transmitted astronomical knowledge in memorable form. Some myths describe the moon being eaten, piece by piece, then regenerating. Others saw the moon as dying and being reborn monthly. Still others describe the moon as a bowl, gradually emptying then refilling. These metaphors helped people, especially children, understand and remember lunar cycles, making abstract astronomical patterns concrete and relatable. Lunar deities in various pantheons often had complex characterizations, sometimes male, sometimes female, sometimes changing gender with phase. The moon might be paired with the sun, contrasted with it, or portrayed as its companion. These mythological frameworks provided context for understanding lunar behavior, making astronomical observation part of larger cosmological understanding. The moon's apparent size changes also attracted attention. When rising, especially near the horizon, the moon can appear enormous, though this is an optical illusion. Ancient observers noted this apparent size variation, incorporated it into their understanding of the moon, sometimes creating myths explaining why the moon appeared larger at certain times. The harvest moon, the full moon nearest the autumn equinox, rises near sunset for several consecutive nights. This provides extended twilight, traditionally allowing farmers extra time for harvest work. Many cultures named this moon specifically, recognized its unique behavior, celebrated it as a gift from nature providing practical benefit. The moon's color variations also received attention, sometimes appearing orange or red, especially when rising through dusty or humid air, occasionally appearing especially bright and white. These variations, caused by atmospheric conditions, were noted, interpreted, sometimes seen as omens or signs. The moon wasn't just a timekeeper, but a communication channel, its appearance conveying meaning beyond mere phase. Lunar eclipses, dramatic events when Earth's shadow crosses the moon, were particularly significant. The moon turning copper red, darkening, sometimes nearly disappearing, created worldwide responses. rituals to help the moon, prayers for its safe return, drums and noise to frighten whatever threatened it. The predictability of eclipses, once discovered, didn't eliminate their emotional impact. Ancient astronomers took pride in predicting eclipses, being able to announce beforehand that the moon would darken, demonstrating this knowledge enhanced authority and prestige. The Babylonians developed eclipse prediction. Chinese astronomers calculated eclipse possibilities. Greek astronomers understood eclipse mechanisms. This knowledge, this ability to predict seemingly magical events, validated astronomical expertise. Solar eclipses, even more dramatic, also connected to lunar timing. Eclipses occur only at new moon, when the moon passes between Earth and Sun. This connection between lunar phase and eclipse possibility was recognized, understood, and incorporated into eclipse prediction systems. Understanding that eclipses followed lunar patterns, that certain new moons were more likely to bring eclipses, shows sophisticated astronomical thinking. The Saros cycle, approximately 18 years and 11 days, brings similar eclipses. After this period, the Sun, Moon, and Earth return to approximately the same relative positions, creating similar eclipse conditions. Ancient astronomers discovered this cycle, used it for prediction, recognized that eclipse patterns repeated over this time span. This knowledge required centuries of observation, records maintained across generations, patient compilation of eclipse data. The moon's distance from Earth varies, creating apparent size changes. At perigee, closest approach, the moon appears about 14% larger than at apogee, farthest distance. This variation affects eclipse types. Perigee full moons appearing as supermoons, perigee new moons creating total solar eclipses, while apogee new moons create annular eclipses. Ancient astronomers noticed these variations, incorporated it into their understanding of the moon. The emotional power of lunar observation shouldn't be underestimated. Watching the moon transform night after night creates a sense of participation in cosmic cycles. The watcher becomes part of the pattern, connecting their individual existence to vast astronomical time frames. This connection, this feeling of cosmic participation, might be lunar observation's deepest gift. Modern people can still experience this. Simply watching the moon over a month, noting its phase each night, observing its changing rise time and position, creates connection to ancient practices. No instruments needed, no special knowledge required, just patient attention. The same moon that ancient peoples watched, carrying the same information, following the same cycles, the practical act of observation connects us across time. Standing outside at dusk, watching for the new crescent, we're doing exactly what Babylonian priests did. Looking up at the full moon, we share the experience of countless previous observers. This temporal connection, this participation in ancient practice, provides something valuable: perspective, continuity, a sense of being part of human story that extends far beyond our individual lives. The moon teaches patience. Its changes are slow enough that rushed observation misses them. You must watch over days, over weeks to see the patterns. This enforced patience, this requirement for sustained attention, might be particularly valuable in modern life's rushed pace. Lunar observation forces slowing down, noticing subtle changes, appreciating gradual transformation. The reliability of lunar cycles provides comfort. Whatever chaos exists in human affairs, the moon continues its ancient pattern. Governments rise and fall, civilizations emerge and disappear, yet the moon waxes and wanes unchanged. This constancy, this reliable repetition, offers reassurance that some things persist despite human turmoil. Ancient peoples found this comforting as well. They lived in uncertain times, facing unpredictable threats, yet the moon's cycle could be trusted. It became a symbol of cosmic order, of patterns underlying apparent chaos, of reliability in uncertain world. This symbolic meaning, layered atop practical timekeeping function, made lunar observation emotionally important beyond mere utility. The moon's accessibility democratized astronomical observation. Unlike planetary motions requiring trained eyes or complex calculations,
Unlike stellar patterns needing dark skies and expert knowledge, the moon was obvious to everyone. Rich and poor, learned and illiterate, all could observe moon phases, all could participate in this basic astronomical practice. This universal accessibility made lunar timekeeping truly communal. Everyone watched the same moon, saw the same phases, participated in the same temporal framework. This shared observation created social bonds, synchronized activities, provided common reference points for coordinating collective action. The calendar wasn't imposed from above, but emerged from shared observation, making it genuinely collective time. The transition to calculated calendars, to time systems not requiring observation, changed this dynamic. Time became something decreed, announced, followed rather than observed. This brought efficiency and precision, but lost the participatory quality of observational timekeeping. We no longer create time collectively through shared observation, we consume time determined elsewhere, calculated by authorities we never see. Perhaps some nostalgia for observational calendars is justified. They connected people to nature, required ongoing attention to celestial patterns, made time something experienced rather than abstractly followed. The trade-offs brought real benefits, but also real losses, including loss of that sense of participating in time's creation through observation. Modern attempts to reconnect with natural time often focus on lunar observation. People commit to watching the moon daily for a month, tracking its phases, noting their own responses to its cycles. These practices, whether spiritually motivated or simply experiential, represent attempts to recover something lost in the transition to calculated time. The moon's mythological richness adds depth to observation. Knowing the stories different cultures told about the moon, understanding how it was personified and honored, enriches the watching. The moon becomes not just astronomical object, but carrier of meaning, holder of stories, connection to humanity's imaginative engagement with cosmos. Different cultures saw different figures in the lunar surface markings. The Chinese saw a rabbit pounding herbs, Europeans saw a man's face. Various cultures saw different animals or people. These paradiac interpretations, seeing faces and random patterns, made the moon more personal, more relatable. It wasn't just a distant object, but a face looking back, a presence watching over Earth. The man in the moon remains familiar Western concept despite astronomical knowledge. Children still learn to see the face, still imagine personality for lunar presence. This persistence of pre-scientific imagery coexisting comfortably with astronomical understanding shows how mythological and scientific knowledge can coexist without conflict. The moon's role in poetry and literature reflects its emotional resonance. Countless poems invoke lunar imagery, countless stories use moon as setting or symbol. The moon represents romance, mystery, melancholy, transformation, depending on context. This rich symbolic vocabulary, accumulated over millennia, makes the moon more than astronomical body, it's a cultural artifact, repository of meaning. Lunar metaphors permeate language. Over the moon for happiness, once in a blue moon for rarity, moonstruck for distracted or romantically affected, moonlighting for secondary employment. These phrases, derived from lunar observation and folklore, show how deeply the moon has penetrated human consciousness and expression. The moon's influence on tides provides a clear physical connection between lunar cycles and terrestrial events. The gravitational pull creating twice-daily tides demonstrates that lunar presence isn't merely symbolic, but has real physical effects. Ancient peoples noticed this correlation, understood that moon and tides were connected, even if the mechanism remained mysterious. Tide tables, predicting high and low water based on lunar position, represent practical application of lunar knowledge. Coastal communities worldwide depend on these predictions, timing activities to tidal cycles. This practical dependence on lunar-influenced phenomena maintains functional connection to lunar observation even in solar calendar cultures. The spring and neap tide cycle, correlating with lunar phases, creates monthly rhythm beyond the daily tidal cycle. Spring tides at new and full moon, neap tides at quarter moons, create predictable monthly patterns. Ancient mariners and fishermen understood these patterns, planned activities accordingly, maintained intimate knowledge of lunar tidal connections. Some traditional fishing practices time activities to lunar phases. Certain fish supposedly bite better at particular moon phases. Night fishing might prefer full moon for visibility or new moon for different reasons. Whether these practices reflect real behavioral patterns or traditional belief, they maintain connection between lunar cycles and human activities. The moon's gradual recession from Earth, moving about 1.5 inches farther per year, is measurable through modern technology. This means that ancient observers saw a slightly larger moon than we do today, and that far future observers will see a smaller moon. Over geologic time, the moon's apparent size and tidal effects have changed significantly, creating different relationships between Earth and Moon in the deep past and distant future. Ancient observers didn't know about the moon's recession, couldn't measure such subtle changes, but the fact that Moon-Earth relationship evolves, that it's not static but changing over vast timescales, adds another dimension to lunar study. The moon we observe is a snapshot in an ongoing process, a momentary configuration in billion-year relationship between planet and satellite. The moon's origin, most likely from a giant impact early in Earth's history, gives it a unique character among solar system moons. It's unusually large relative to its planet, has unusual orbital characteristics, and profoundly influenced Earth's development. The moon stabilized Earth's rotation, its tides may have influenced the evolution of life, its presence shaped our planet's history in fundamental ways. This deep connection between Earth and Moon, this billion-year relationship, provides cosmic context for human lunar observation. We're not just watching a distant object, we're observing our planet's companion, the celestial body that helped make Earth habitable, that continues to influence terrestrial conditions. This relationship, ancient beyond human comprehension, yet observable in simple tidal flows, connects us to deep cosmic time. The moon's future remains Earth's companion for billions of years yet. Eventually, in the far future, its recession will carry it so far that total solar eclipses become impossible, that tides diminish, that its apparent size shrinks.
But these changes occur over timescales vastly exceeding human civilization, even human species' existence. For all practically relevant time, the moon continues its present dance, reliable companion, faithful timekeeper. This longevity, this endurance beyond human timescales, makes the moon a symbol of permanence. While everything human is temporary, the moon persists. Civilizations that watched it have vanished, their monuments crumbled, their languages forgotten, yet the moon continues, essentially unchanged. This permanence amid but these changes occur over timescales vastly exceeding human civilization, even human species' existence. For all practically relevant time, the moon continues its present dance, reliable companion, faithful timekeeper. This longevity, this endurance beyond human timescales, makes the moon a symbol of permanence. While everything human is temporary, the moon persists. Civilizations that watched it have vanished, their monuments crumbled, their languages forgotten. Yet the moon continues essentially unchanged. This permanence amid impermanence, this constancy amid flux, gives lunar observation particular poignancy. We watch the same moon that illuminated the first human steps, that witnessed the rise of agriculture, that marked time for ancient astronomers, that hung over historical events great and small. Every human who ever lived shared this one constant, this moon, this faithful companion of Earth. This universal human experience
connection to all previous observers through shared object of observation, transcends cultural and temporal boundaries. As we prepare for sleep, the moon continues its journey. Whether visible or hidden, whether attended to or ignored, it proceeds on its ancient path. The orbit persists, the phases cycle, time flows onward, marked by celestial rhythm. We rest under moon's watch, as countless humans have rested before, as countless more will rest in times to come. Small and brief beneath eternal cycles, yet connected to something vast through simple act of existing under this moon. The gentle silver light, or the darkness of moon's absence, watches over dreams. The tide puller, the time marker, the ancient companion, continues its rounds. Sleep comes easily under such eternal watch, under such faithful presence, drifting into rest with the comfort of cosmic constancy, the reassurance of patterns that persist beyond individual lives, the peace of participating, however briefly, in something timeless and vast and beautiful. Sleep now, under the moon's gentle light or in the darkness of its absence. Dream of ancient watchers, of patient observation, of patterns emerging from chaos. Let the moon, in whatever phase it currently displays, watch over your rest as it has watched over countless billions of sleeping humans across the ages. The timekeeper continues its rounds, the calendar turns, the eternal cycle proceeds, and we, small and brief, nonetheless participate in something vast and timeless simply by existing under this moon, this ancient, faithful, beautiful companion of Earth, marking time while we dream away the hours in peaceful, lunar-watched sleep. The moon will continue its dance, regardless of human attention. Tides will rise and fall, phases will wax and wane. The monthly cycle will continue. But choosing to watch, to notice, to participate in this observation connects us to all previous watchers. We join an unbroken chain stretching back to the first humans who watched the night sky, who noticed patterns, who began humanity's long conversation with the cosmos. As evening settles, as darkness deepens, the moon rises, carrying its ancient message of time's passage. Whether crescent or full, whether watched or ignored, it marks the months, patient, eternal, reliable. The same timekeeper that organized ancient societies, that determined festivals and planting, that structured human life for millennia, still hangs in our sky, still offers its gentle, constant rhythm. The moon's changing position in the sky through the year adds another layer of complexity. During winter, in northern latitudes, the full moon rises early and climbs high, remaining visible for most of the night. The moon follows a path similar to summer sun, high in the sky, providing maximum illumination during long winter nights. This was noticed by ancient peoples, appreciated as a gift from nature, winter's compensation for short days. Summer full moons, by contrast, stay low in the sky, rising late and setting early. They follow paths similar to winter sun, skimming along the southern horizon. The moonlight is less intense, covers fewer hours, provides less nighttime illumination. Ancient observers noticed this annual pattern, incorporated it into their understanding of celestial cycles. The moon's rising and setting points on the horizon also shift. Over the course of its 18.6-year nodal cycle, the moon's extreme positions, its standstills, move from maximum to minimum range. At major standstill, the moon rises and sets at its most extreme points, far north and far south. At minor standstill, its range is minimal, rising and setting within a narrow arc. This long cycle, difficult to detect without decades of observation, was apparently known to some ancient cultures. The megalithic alignments in Britain, if they do mark lunar standstills, demonstrate recognition of this cycle. The ability to identify a pattern that takes nearly 20 years to complete, that requires comparing observations separated by years, shows remarkable dedication and record-keeping. The nodes themselves, the points where the moon's orbit crosses the ecliptic, were understood by ancient astronomers. These nodes are where eclipses occur, where the sun, moon, and earth align in the same plane. The nodes gradually move, precessing around the ecliptic, completing the circuit in 18.6 years. This nodal precession creates the long cycle, affecting extreme lunar positions, influencing eclipse patterns. Babylonian astronomers tracked the nodes, understood their importance for eclipse prediction. They developed tables showing nodal positions, calculating when favorable eclipse conditions would occur. This knowledge, combined with understanding of the Saros cycle, allowed increasingly accurate eclipse prediction. The mathematics was complex, but the Babylonians mastered it, becoming expert eclipse calculators. The lunar calendar's interaction with seasons created practical challenges that ancient people solved ingeniously. When purely lunar months drifted too far from seasonal reality, when the harvest moon appeared in the wrong season, adjustments were made. The intercalary month, inserted to realign the calendar with year, represents ancient problem-solving, flexible systems adapting to astronomical reality. Different cultures used different triggers for intercalation. Some watched for specific stars appearing at dawn. Others monitored agricultural conditions. Others calculated based on accumulated day counts. All sought the same goal, keeping lunar months loosely aligned with solar year, but approaches varied based on local needs and astronomical knowledge. The Hebrew calendar's 19-year cycle represents an elegant solution to the intercalation problem. 7 times in 19 years, an extra month is added, following a specific pattern. This system, once established, runs automatically, requiring no observational decision-making about when to intercalate, yet it maintains the connection between months and moon, years and seasons with remarkable accuracy. The pattern of intercalation, years 3, 6, 8, 11, 14, 17, and 19 receiving extra months, creates near-perfect alignment between lunar and solar cycles. The accumulated error is minimal, requiring adjustment only over centuries. This mathematical elegance, this solution that balances lunar months with solar year, represents pinnacle of ancient calendrical thinking. The emotional and spiritual dimensions of lunar observation extend beyond practical timekeeping. Many traditions saw the new moon as symbolic rebirth, opportunity for new beginnings, fresh starts. The waxing moon represented growth, increase, building toward fullness. The full moon marked completion, achievement, maximum potential realized. The waning moon suggested decrease, release, letting go of what no longer serves. These symbolic associations influenced behavior. People might begin projects at new moon, hoping to grow with lunar increase. They might make commitments at full moon, when energy peaks. They might release old patterns during waning moon, embracing decrease as natural part of cycles. Whether these practices had objective effects or worked through psychological suggestion, they connected human activities to cosmic rhythms. Menstrual synchrony with lunar cycles, widely claimed but scientifically debated, represents another potential connection. Some women report menstrual cycles aligning with moon phases, beginning at new or full moon. Studies show mixed results, some supporting correlation, others finding none. The question remains open, neither proven nor disproven definitively. The approximate equality, lunar month around 29.5 days, menstrual cycle averaging 28 to 29 days, is suggestive. Whether this similarity is coincidental or reflects some deeper connection has been debated for millennia. Ancient peoples certainly noticed the correlation, built mythologies around it, associated moon with fertility and feminine power. Modern studies of biological rhythms, chronobiology, investigate whether organisms respond to lunar cycles. Coral spawning, timed to specific moon phases. Certain fish species migrating or reproducing in sync with lunar cycles. Marine worms rising from seafloors at particular lunar phases. These documented lunar rhythms show that some creatures definitely respond to moon cycles.
the mechanism remains unclear. Do organisms sense lunar gravity? Do they respond to tidal rhythms caused by lunar position? Do they use moonlight as a cue? Various hypotheses exist, but definitive answers remain elusive. The fact that lunar biological rhythms exist, however, suggests ancestors' attention to moon wasn't purely cultural, but potentially responding to real biological influences. Human sleep patterns might also be affected by lunar cycles. Some studies suggest people sleep less during full moon, though others find no effect. The question remains controversial, complicated by artificial lighting, by individual variation, by difficulty controlling for confounding factors. But the possibility persists that lunar cycles might influence human biology in subtle ways. The moon's psychological impact is undeniable, regardless of biological mechanisms. Full moons affect mood. Many people report feeling more energized, restless, emotionally activated. Whether this is lunar influence or cultural expectation is difficult to determine. But the association between full moon and heightened emotional states appears cross-cultural, suggesting either biological basis or deeply rooted cultural pattern. The word lunatic, derived from lunar, reflects historical belief that the moon affected mental state, temporary insanity, mood swings, erratic behavior, all attributed to lunar influence. Modern psychiatry finds little evidence for this, but the cultural belief persists. Emergency rooms, police, mental health workers often report believing that full moons bring more crises, though statistical analyses generally don't support this perception. This disconnect between subjective belief and statistical reality interests psychologists. Perhaps full moons are simply more memorable, creating confirmation bias. Perhaps cultural expectation creates self-fulfilling prophecy. Or perhaps subtle effects exist that current methods can't detect. The question remains open, inviting continued investigation. Walking under full moon has a timeless quality. The world transformed by moonlight, shadows soft and blue, details visible yet mysterious. Ancient peoples experienced this monthly, the landscape they knew intimately appearing different, magical under lunar illumination. This regular transformation, familiar becoming strange, might have deepened the moon's symbolic power. Night sounds under full moon seem amplified. Crickets, frogs, nocturnal birds, all more noticeable when you're outside watching the moon. Ancient moon watchers would have been immersed in these soundscapes, their observations accompanied by nature's night chorus. The multi-sensory experience of lunar observation, visual patterns combined with nocturnal sounds, created rich memory associations. The temperature patterns associated with lunar phases might have been noticed also. Clear nights, necessary for moon observation, tend to be cooler, heat radiating into space. Cloudless full moon nights can be quite cold, despite brilliant illumination. Ancient watchers, spending hours observing, would have felt these temperature variations, associated clear skies and moonlight with nighttime chill. Dew formation, heavier on clear nights, might have been connected to lunar phases. The grass wet under full moon, crystals sparkling in moonlight. Ancient peoples walking to observation points would have felt this dew on their feet, associated this moisture with lunar presence. Whether dew actually correlates with moon phase or just with clear skies necessary for moon viewing, the association would have formed. The moon's relationship with clouds creates another dynamic. Clouds obscuring the moon, moving across its face, parting to reveal it again. The interplay of light and shadow, moon appearing and disappearing, creates dramatic nighttime displays. Ancient observers watching for specific lunar events would have been frustrated by clouds, yet also witnessed these beautiful interactions between moon and atmosphere. Atmospheric optical phenomena around the moon also caught attention. Halos, rings of light formed by ice crystals in high clouds appearing around full moon. These halos, often spanning significant portions of sky, would have been interpreted as signs, omens, messages. The optics causing them weren't understood, but the regular occurrence of halos under certain conditions might have been noticed. Moondogs, paraselene, bright spots appearing beside the moon under specific atmospheric conditions, are less common, but equally striking. Ancient observers seeing these phenomena might have wondered at their meaning. Were these companion moons, divine manifestations, natural variations? Without understanding atmospheric optics, such phenomena would have seemed mysterious, potentially significant. The moon's reflected earthshine, the faint glow visible on the dark portion of Crescent moon, shows Earth's reflection illuminating lunar surface. Ancient observers with keen eyesight might have noticed this subtle effect. Some cultures developed explanations: the old moon cradling the new, or the moon showing its full face faintly even when mostly dark. Understanding moon phases, that the moon shines by reflected sunlight, that its changing appearance results from viewing angle, wasn't universal in ancient times. Some cultures understood this, others had different explanations. The Greeks definitely grasped the geometry.
Anaxagoras was even exiled for suggesting the moon was a rocky body reflecting sunlight. So threatening was this materialistic explanation to religious authorities. The transition from seeing the moon as divine being to understanding it as astronomical body reflects broader shift in human thought. Yet even with astronomical understanding, the moon retains emotional and aesthetic power. Knowing that it's reflected sunlight doesn't diminish its beauty. Understanding orbital mechanics doesn't make the full moon less stirring. Scientific knowledge and emotional response coexist comfortably. Ancient astronomers who understood lunar mechanics still participated in religious observances around moon. The technical and spiritual weren't separated, as they sometimes are today. One could calculate lunar positions mathematically while also honoring moon deities, seeing no contradiction. The moon was simultaneously astronomical object and sacred presence, both understandings valid in their contexts. This integration of technical and spiritual understanding characterizes much ancient astronomy. The Babylonians calculated planetary positions while also interpreting them astrologically. Chinese astronomers predicted eclipses while also reading them as omens. Maya astronomers tracked Venus while honoring it as deity. The divisions between science and religion, between observation and interpretation, were less rigid than in modern thought. The legacy of lunar calendars continues in unexpected ways. Even solar calendar cultures retain lunar elements. Easter's calculation, based on spring equinox and subsequent full moon. Chinese New Year, falling on new moon between January 21 and February 20. Islamic months, purely lunar, interacting with solar calendars in majority non-Muslim countries. These overlapping systems show continued influence of ancient lunar timekeeping. The persistence of lunar observation, even where not strictly necessary, suggests its deep roots in human consciousness. We're drawn to watch the moon, to mark its phases, to feel connected to its cycles. This might be cultural inheritance, or might reflect something deeper, biological or psychological predisposition toward lunar attention. The moon's reliability makes it perfect for teaching astronomical observation. Children can easily track moon phases, see patterns develop over weeks. The cycle is short enough to observe complete, long enough to require sustained attention. Many people's first astronomical observations are lunar, beginning a lifetime of skywatching with Earth's closest celestial neighbor. Educational programs often start with lunar observation for this reason.
Students can maintain moon journals, sketching phases, recording observations, seeing firsthand how patterns emerge from data. This experiential learning, connecting abstract concepts to direct observation, follows ancient tradition of learning astronomy through patient watching. The moon serves as a gateway to understanding orbital mechanics, to grasping how perspective affects appearance, to recognizing patterns in natural phenomena. These lessons, learned through lunar observation, transfer to understanding other astronomical concepts. The moon teaches us how to be astronomers, how to observe patiently, how to recognize patterns, how to connect observations to deeper understanding. Modern lunar observation, whether casual or systematic, continues the ancient tradition. Amateur astronomers photograph the moon phases, track its motion against stars, observe its interaction with planets. This hobby, pursued by thousands worldwide, maintains continuity with ancient watchers. The same skills, the same patience, the same satisfaction in successful observation. The emotional experience of watching moonrise hasn't changed. Standing at sunset, watching the eastern horizon, waiting for the moon to appear. The first glimpse, the gradual rising, the moon climbing into darkening sky. Ancient observers felt what we feel, the quiet joy of witnessing this daily miracle, the connection to something larger than individual existence. Each moonrise is unique. Different seasons bring different rising points. Different atmospheric conditions affect color and clarity. Different phases create different emotional impacts. The crescent moon rising delicately in twilight. The full moon surging up massive and golden. The gibbous moon appearing in daylight. The last crescent rising just before dawn. Each manifestation beautiful, each worth watching. The moon setting is equally beautiful, though less often observed. The west-facing view as moon descends toward the horizon. The way it seems to grow as it lowers, another optical illusion, but striking nonetheless. The final moment before it disappears, hanging on the horizon, then gone. Ancient watchers who stayed through the night would have witnessed both moonrise and moonset, bracketing their observations with these aesthetic experiences. The dark of the moon, those nights without moonlight, offer different experiences. The stars shine more brilliantly without lunar interference. The Milky Way appears more distinct. Fainter celestial objects become visible. Ancient astronomers appreciated these moonless nights, using them for observations impossible when moonlight washes out fainter lights. The rhythm of bright and dark nights, created by lunar phases, would have structured ancient nighttime activities. Moonlit nights for traveling, social gatherings, activities requiring visibility. Moonless nights for astronomical observation, for rest, for different ceremonial practices. This natural alternation, 2 weeks of increasing moonlight, 2 weeks of decreasing, created temporal structure to nighttime life. Modern light pollution has largely erased this pattern. Urban dwellers rarely experience truly dark nights, moonless periods no darker than moonlit because of artificial lighting. This loss represents disconnection from natural rhythms that structured human life for millennia. The moon still waxes and wanes, but its practical impact has diminished, its phases less relevant to daily activities. Yet interest in lunar observation persists, perhaps even increases as direct practical relevance decreases. People seek out dark sky sites, traveling to remote locations to experience moonless starry nights. They watch for full moons, make special efforts to witness moonrise. This seeking of lunar experiences, when not practically necessary, suggests deep human affinity for lunar observation. The moon's future as timekeeper remains uncertain. Solar calendars dominate worldwide for civil purposes. Yet lunar observation continues for religious reasons, for personal interest, for maintaining traditional practices. This dual system, official solar calendars and maintained lunar observation, might persist indefinitely, balancing practical convenience with spiritual and cultural continuity. Technology has changed observation methods, but not the essential experience. We can now photograph the moon, view it through telescopes, calculate its position with computer precision. But looking up with the naked eye, seeing the crescent in twilight or the full moon climbing above horizon, this remains fundamentally unchanged. The same moon, the same human response, the same sense of wonder and connection. The moon will continue its ancient dance regardless of human attention or interpretation. Its orbit will proceed, phases will cycle, tides will rise and fall. We can choose to notice or ignore, to calculate or simply observe, to integrate lunar awareness into our lives or live by artificial divisions of time.
The moon offers itself, patient, reliable, beautiful, marking time as it has since before humans existed, as it will long after we're gone. Perhaps the greatest gift of lunar observation is perspective. Watching the moon, we connect to ancient observers across millennia, across cultures, across vast spans of human history. We're doing what our distant ancestors did, looking up, marking time by celestial patterns, feeling ourselves part of cosmic rhythms. This connection, this participation in timeless practice, puts our individual lives in perspective, reminds us we're part of something larger. The ancient watchers, standing on their temple platforms, gazing from their hilltops, sailing on their oceans, all watched the same moon we see. Their observations accumulated over generations, creating the understanding we inherit. We're the beneficiaries of millennia of patient watching, of careful record-keeping, of transmitted knowledge. When we observe the moon, we honor that long chain of watchers. We participate in humanity's ancient conversation with the cosmos. As night deepens, as the moon continues its journey across the sky, we can imagine all those previous watchers, the Babylonian priests on their ziggurat, the Egyptian astronomers at their temple, the Chinese court observers, the Maya lords tracking Venus and moon together, the Celtic druids on their hilltops, the Islamic faithful seeking the new crescent, all watching, all marking time, all connected across centuries by their shared observations. And now, as we prepare for sleep, the moon continues overhead, following its ancient path. Whether we watch or sleep, the cycle proceeds. The moon waxes toward fullness or wanes toward darkness. Time flows onward, marked by lunar phases, measured by celestial cycles. The great cosmic clock ticks away the months, patient, eternal, indifferent to human concerns, yet intimately connected to human life through millennia of observation and cultural meaning. Sleep now, under the moon's gentle light, or in the darkness of its absence. Dream of ancient watchers, of patient observation, of patterns emerging from chaos. Let the moon, in whatever phase it currently displays, watch over your rest, as it has watched over countless billions of sleeping humans across the ages. The timekeeper continues its rounds, the calendar turns, the eternal cycle proceeds, and we, small and brief, nonetheless participate in something vast and timeless, simply by existing under this moon, this ancient, faithful, beautiful companion of Earth, marking time while we dream away the hours in peaceful, lunar-watched sleep.